I think we can all understand the value of a rich type system. Oftentimes we need it because we don't want ourselves or anyone else touching our variables. We don't want weird mutations out of nowhere. And since you might be reading this particular variable, for example, if we can get a student variable, maybe you don't want anyone else touching this variable ever again, and you just want to let it be. You don't want anyone touching this, mutating this, or something like that, which could break the entire app. You don't want it to happen. So you might type it like this. And then when someone else or you by mistake tries to mutate it, it will throw an error. It will say, hey, you cannot do it because you can only read it. But when the type starts getting bigger and bigger, for example, you have so many of these over here, they don't want to do it. So how do we do that, right? Let's create a new type. Let's create a generic type, which will take an input as a generic. And then we will say, hey, take each and every element and assign this. So what is happening over here is that you take each and every key, so k in key of t, so t will be replaced by the type of student. So type student, let's just say. So when we give read only the student type over here, this will be replaced by the student type, and k in the keys of t, so it will go through each key, id and name in this case, and it will assign the type read only type. So basically read only will be attached to each and every key in this type. So that's how you use it. Now if I want to say, hey, const immutable student equals to, which is a read only type for the student, and I say, hey, name equals to not mobile and id equals to some number. And when I try to mutate this immutable student, so for example id equals to, you can't do it because it's read only. Each and every type in this thing is read only student. So you can only read each and every property of this student and not mutate any of it. That's the point. All right, bye.